You're welcome to this lecture, and we are going to be moving a step further, looking at measurement of variation or measures of variation. Okay, measures of variation are statistics that measures how or the extent to which numerical data tend to spread around the mean. That is, to what extent do they spread around the mean? That's what measures of variation try to codify. Okay, the first one is range. The range is the difference between the highest and the lowest number in a given set of data. So all you have to do is to find the highest number and the lowest number, find the difference. That's the range. Even if it's their group data, find the highest of the group data, find the lowest of the group data, subtract. Okay, then mean deviation. Mean deviation is the variation of the of data around the mean. You understand? It's a kind of how do I put it now? It's a kind of measurement of variation as well, and it's given by this formula: x minus x bar over n, where there are no frequency. X here is the individual elements, the x bar is the mean. Where there are frequencies, you have summation f bracket this. That's mean deviation. Then you have the variance and the standard deviation. The mean deviation is also used as the basis for the variance. Okay, square of the deviation, deviation divided by n, or divided by the summation of the frequency, will give us the standard deviation. Or the formula can be adjusted like this. We have various variation of the formula, and don't forget the square root of the variance is equal to the standard deviation. Okay, so that's the interrelationship between them. Okay, before I move on to the other ones, let's look at this scenario to illustrate the mean deviation, the variance, and the standard deviation. Alright, this example I brought it forward from the previous one example we did. This is the class number, this is frequency, and this is the class mark. Don't forget, the class mark is the summation of the upper and lower class boundary divided by 2. Okay, now we are looking for the mean deviation, but before we find the mean deviation, we have to find the mean. Then for us to find the mean, we have to multiply fx. That's 15, 64, 130, 18 times 9, that's 162, 23 times 8, that's 184, 28 times 7, 196, and then 99. So our fx will be summation of everything, and that gives us 850. Okay, now if our fx is 850, then our mean is summation fx over summation f. Summation f here, 13 plus 10, 23 plus 9, 32, is 40, 50. Okay, that's 850 over 50, and that gives us 17. That's 85 divided by 5, 70. I hope we are still together. Okay, now the next thing is to find the deviation around the mean, and the way to do that is x minus x bar. Don't forget, you disregard the sign there. We are not using the sign under the mean deviation. Okay, so 3 minus 17, that's 14. 8 minus 17, that's 9. 13 minus 17, that's 4. 18 minus 17, 1. 23 minus 17, that's 6. 28 minus 17, that's 11. And then lastly 10. Okay, then multiply by the frequency. 14 by 5, that's 70. 9 by 8, 72. 4 by 10, 40. 1 by 9, 9. 6 by 8, 48. 11 by 7, 77. Then 10 by 3, 30. So our summation is, sum this up, it will give us 364. So our mean deviation, which is given our summation f bracket x minus x bar over summation f, is 364 over 50, and that's given us what? 7.28. That is our mean deviation. Now we've looked at variance as well. We can use this equation to get the variance as well. You have to square the deviation and then multiply by the frequency. So you square this, 14 square times 5, and then you do that throughout. 14 square times 5, 9 square times 8, 4 square times 10. You understand? You do that throughout, and then the summation you get, you divide by summation f. That will give you the standard deviation. But that might be a little bit cumbersome, so the method is not usually used. The other method that is used is the formula summation fx squared minus summation f minus summation fx plus summation f all squared. That's the variance. So in that case, let's find fx squared. You square x and you multiply by the frequency. You can do it one after the other, but I'm going to do it together here. 3 squared, that's 9, times 5, that's 45. 8 squared, 64, times 8, 512. 13 squared, 169, times 10, 1690. 18 square, I think that should be 284, 264, times 9, as 18 square, 324, sorry, times 9, 2916. Then 23 square, 529, times 8, 4232. And then 28 square times 7, 5488. And lastly 33 square times 3, 3267. Okay, then summation, now 18,150. So that means our variance is 18,150 over 50 minus 850 over 50 square. Okay, 18,150 divided by 50, that's 363, minus 17 square, that's 289. So the variance is 74. Okay, the standard deviation is the square root of the variance, square root of 74. Square root of 74. What do we have? That's 8.60. Okay, so our standard deviation is 8.60. You can as well use the coding method for the standard deviation. I gave it also in the formula. In that case, you have to find fu. Okay, you have to find u, fu, and fu square. Okay, now taking an assumed mean, let's take 18 as our assumed mean. 18, let's take 18 as our assumed mean. So 1 2 3 4 1 2 3 4, 18 as our assumed mean. 0 1 2 3 minus 1 minus 2 minus 3. FU, this minus 15 minus 16 minus 10 0 8 14 and 9. Okay, 14 plus 8 plus 9 is 31 minus 15 minus 16 minus 10. That gives us minus 10. And then FU square, you square U and multiply by F. That's 9 times 5, 45. 4 times 8, 32. 1 times 10, 10. 1 times 8, 8. 4 times 7, 28. And 9 times 3, 27. So let's add that together. 45 plus 32 plus 10 plus 8 plus 28 plus 27, and that's 150. Now using the formula summation FU square over summation F minus summation FU over summation F square, so it's going to be summation FU square 150 over 50 minus 10 over 50 square. Okay, 150 over 50, that's 30. Sorry, this is 3, not 30. Minus, this is minus 0.2 square, that's minus 0.04 times the class width, the square of the class width, 5 square. So that's 2.96 times 5 square, and that gives us 25 times 2.96, that gives us 74. Okay, so that's how to go about the measure of variation. That's the variance. If you want to find the standard deviation, you find the square root. The next measure of variation that we're looking at is the semi-interquartile range. The semi-interquartile range is given as Q3 minus Q1 over 2. Don't forget we looked at the quartile, calculation of the quartile as a measure of partition the other time. Okay, so you calculate the dot quartile, the first quartile, find the difference and divide by 2. It's also known as the semi-interquartile range, is also known as the quartile deviation. The quartile deviation. Okay, the Q3 is also known as the upper quartile. The Q1 is also known as the lower quartile. Then the other measure, another measure is the coefficient of variation. It's not a measure in itself, it's derived from the other types of measure, and it's used when you are trying to compare two distributions that are not measured in the same unit. Then you use what is known as coefficient of variation, and it's given as standard deviation over mean times 100. This formula here is technically known as coefficient of standard deviation, but generally known as coefficient of variation. The reason is that there are other measurements of coefficient of variation. We have coefficient of quartile deviation, which is given as quartile deviation divided by the median. The quartile deviation divided by the median. Then we have the coefficient of mean deviation, is given as the mean deviation over the mean. And then the popular one, the quartile of standard the coefficient of standard deviation. Okay, the lower distribution that has the distribution that has the lower coefficient of variation is chosen over the one that has higher distribution. Okay, another measure we're going to be looking at is skewness. Skewness measures the asymmetrism of a frequency distribution. That's the departure for asymmetry. That's what skewness tries to measure. We have about 2 or 3 measures of skewness. First one is the Pearson measure of skewness, and is given as mean minus mode over standard deviation, which is the same thing as 3 brackets mean minus median divided by the standard deviation. For a positively skewed distribution, the mean is always greater than the mode, and if it's negatively skewed, the mode is greater than the mean. The median is in between the mean and the mode, depending on the kind of distribution you are looking at. Then the second measure is the quartile measure of skewness. The quartile measure of skewness is given as Q3 plus Q1 minus 2Q2 over Q3 minus Q1, while the percentile coefficient of skewness also follows similar pattern. That's P90 plus P10 minus 2P50 divided by P90 minus P10. That's the percentile measure of skewness as well. The last measure of variation we're going to be looking at is what is known as Kutosis. Kutosis measures the degree of pickedness of a distribution, that is how high a distribution is. Let me give a diagrammatic illustration. Look at these 3 types of distribution. Okay, this is a leptocotic distribution. A distribution as is high pickedness or high frequency distribution. Then this is a platycotic. It's not high, it's very low. And this is a mesocotic, it's normal. Okay, those are the 3 measures of kurtosis. Now we have various methods of measuring kurtosis, among which are the moment measurement of kurtosis, as well as the quartile percentile measure of kurtosis. The moment measure of kurtosis gives the kurtosis as the 4th moment divided by the standard deviation raised to power 4, while the quartile percentile method estimates the kurtosis as Q over P90 minus P10, where Q is the semi-interquartile range or the quartile deviation, which is Q3 minus Q1 divided by 2. So these are the various measures of variation. Just go over it, and I hope by now you understand how to compute and the meaning of some of these measures. Thank you.